Okay, nice to meet you. I'm Arkadiusz Sokołowski and we'll be talking about data-oriented programming in Java. Here is the link to the Slido where you can ask questions, and at the end I will try to answer all of them. So everyone joined already here? Yes. Okay, so let me move to the actual presentation. And what I'm talking about, it's called data-oriented programming in Java. The inspiration for this talk actually came out from, all the new Java functionalities that are being introduced starting from Java 16, like records, pattern matching, and so on and so on. They are gaining more and more popularity, but still when it comes to some usages, a lot of people still don't use that, don't know how to use that, or simply doesn't have it embedded in a head that they could use a record instead of class, for example, in this particular instance. So I started to explore this whole area, how to present it, and I came up with a data-oriented approach that I will be exploring and look at it from a couple of different perspectives. First, strictly from data-oriented programming. Then I will compare it a little bit to data to DDD. You know DDD, yeah? I guess so. And then we will look at some popular tools that we are using for persistence, like JPA, jOOQ, and pure JDBC. How does it relate? How does it work? Does it work good or bad with data-oriented programming? And these all new Java features that are used for that. A few words about me. I'm Arkadiusz Sokołowski, working as a software engineer for over 25 years already. Initially, I put 20 years over here, but then I counted the years and I was scared. And also working as Java lecturer at university. Right now, I'm working for InPost. Okay, so let's start from the history, from the object-oriented programming, because we're talking about Java, and Java is object-oriented programming. So first question is, what actually is object-oriented programming? And I guess you all know that this is just a paradigm of programming where we have objects, we can manipulate the object state with methods, data is modeled as fields, and the code as methods. What actually object-oriented programming is for? So it was created for a couple of reasons. One of them is to manage the software complexity. If we have everything in one place, not isolated, it's much harder to maintain it together. And to manage this natural complexity, we put some techniques to make it easier, simply. And how this complexity is being managed? There are these particular techniques that we all know. So there is an encapsulation that we isolate the objects. There is an abstraction and inheritance mechanism that we can model mainly the behavior and reuse some aspects of the objects. And then we have also polymorphism and overloading. So these all are terms well known in the Java world, in the object-oriented world, and they perfectly match into the Java language that was created within this paradigm in mind, and it works just fine. And there are some pros, of course, for object-oriented programming. First, it deals with the complexity, so complexity is being managed somehow. It's not everything distributed, just managed. It allows to define boundaries, and boundaries are very important when we're dealing with anything more complex that we can deliver by multiple parties, just defining interface between some entities. Boundaries are also important in terms of security, for example, and we have boundaries in computing everywhere, actually starting from processors, where we have virtualization, levels of virtualization, kernel that is separated from user spaces, and so on. And object-oriented also fits into this paradigm with defining boundaries. Also, it enables some kind of modular reasoning. So we are thinking about our big program or some system in more distributed terms, in terms of we are decomposing to some components, modules, and trying to fit them together, which make it easier to do maintenance, to develop it and scale these solutions. And it also introduced state management. So when we have encapsulated object, we can manage its state internally, modify, mutate the state, do something that is kept within the boundaries that we have defined. But there are some cons of the object-oriented programming, and I guess we all know them. Abstraction is easy, and if it is easy, it's easy to abuse. Yeah, you know that kind of classes. Who didn't see a class like that, and lot of different interfaces, classes, abstract factory, whatever builder, yeah. Hold the hierarchy just to create a couple of instances. So this is not usage of object-oriented programming. It's actually abusage of that paradigm, but it is easy and it brings in some sense of abstraction and reusage of some things that not necessarily should be reused. It has a tendency to bring in complexity, because when we define some complex object hierarchy and we encounter something that doesn't fit into, we do modify that or add some additional hierarchy and makes it bloated and ending up with, for example, this one or something even worse. For smaller programs, it's simply not needed. When we are writing something that fits into 100 lines or has only 3 or 5 domain entities or objects, we don't need this whole burden of object-oriented programming, which comes with a lot of complexities. Right now, when we are mainly writing not a big monolith, but rather microservices and trying to keep them micro, it's not always necessary to do the full bloated model that has a lot of inheritance and polymorphism and so on and so on. Also, it's not best with stateless processing when we have some isolated requests. Also, it's, again, something small, something very concise, should be processed quickly, and there is no need to have it with all this objects burden modeled. And objects are hard to serialize. When we think about Java serialization mechanism, it's not transparent, it's dangerous in terms of security, it's insecure, not secure. When we have some objects that have circular dependencies, then okay, yeah, let's not explore that. We all know all the problems related to that. And the data is about serialization. Yeah? We have data serialized, we need to deserialize that. So matching this with objects in Java and in OOP in particular, in general, is not very easy and nice. So let's now move a little bit, shift a little bit to data-oriented programming. And this is not exactly something absolutely new, of course. This is just another approach, another angle to look at the programming. And we can look at this as a programming style where actually data is not modeled as fields, but as a data. Yeah? We keep data as a data represented in some language terms that are representing, well, data. The code is separated from data. When we have objects, we have data and code together, fields and methods. With data-oriented, we have code separated. We have the data, and we have a code that operates on this data. Later, we'll look into some examples of records, of course, and there will be some code, but this code will perform 2 very particular functions that we will discuss later. This is also very important. Data is simply immutable. When we have data, we cannot mutate this data. We have just the data, we received it from somewhere, and this data is as it is. It cannot be mutated by us. We can, of course, do some operation on this data, which will end up with some data modification, and we will end up with some data storage that is different piece of data, but then it's different piece of data, not the data that we just received to process. We're just outputting some other data. Is it to database or to the server as a server response? But that's different data than the original one that we received. So the data itself is not mutable. It's just is, and we can do something on that, on top of that, but not modify. And data that we are looking at, maybe in form of stream or events or stream of events that we are getting in, doing something and outputting something. And some common operations with data, pattern matching, transformations, we know that. And we have a data, we do something with that and output something. So at the high level, as we can compare it, in object-oriented programming, the subject is an object. I like that sentence. That the main entity, something we are focusing on, are objects with fields and methods. In data-oriented programming, we are focusing on the data. It's in the very middle everything of we are doing. So what actually it is in Java context, how we deal with the data. Usually we have it in some stringy form. It's XML, JSON, YAML, whatever it is. We have some tools to manipulate data. This is just to give some context how we can manipulate with data, and some other approaches to data manipulation. It doesn't have to be always Java, but these tools that are over here are kind of limited. They have some limitations, and Java and other programming languages, but we're talking about Java, are bringing in some more tools that are making this data transformation simpler, maybe not always simpler, but for sure more secure and robust. Java has a strong static typing that brings in all the things that are related to this, like safety, maintainability, readability, moving a lot of errors from the runtime that actually can happen there to the compilation time, because of introducing these types, because of the compiler is able to catch out a lot of things that otherwise are detected at runtime. And with data-oriented programming, with this data-based approach, it's strongly encouraged, and it's embedded in the language to encourage that approach, that everything that is possible should be detected at the compilation level. And data, well, because it's just a string, it's easy to serialize. Of course, in Java, we can represent it somehow, but for example, with records, it is, and in the future will be much easier to serialize this data. Of course, we still may have a problem with circular data, but when modeling the data, when getting the data, we just need to make sure that that there is no circular dependencies. So we're getting to the particular tools that Java provides us to deal with this whole data-oriented programming. We have a records. They were defined in Java 16 with this JEP. And they introduce some very interesting properties like immutability by default. And this immutability is very deep immutability. As you know, we can, even if we have immutable class in Java, you know, final, private, and so on, all the fields, still we can mutate it using reflection. We just, you know, set accessible to true, modify the field, set accessible to false, and we modify the state of the object that we couldn't. With records, it's not possible. Even with reflection, these objects are closed for the modification. So they are, in this terms, secure by default. Some common methods are generated within the records, because records still is a class, but with some limitations. Yes, and some methods like, well, not getters, it's called accessors to the fields. Accessors are being generated, plus hash code, plus equals. This is being provided. Of course, we can override that if we want, but usually there is no need to. This is to represent the data and uses the data to provide these methods. Serialization. Serialization not in terms of making it into binary form that is stored, sent to the wire, not the bytes itself, but serialization from primitive types or more primitive types, and deserialization, the construction, to more primitive types like int, strings, and so on, basically to the fields of this record. And another important aspect is validation at boundary. So when we are creating a record, we should take care about making states that are illegal unrepresentable. For example, if we have a field that is a string and it cannot be null in the context of this record, we should check it during the creation of the record at the constructor. And if it occurs that the string is null as a parameter, we should throw an exception or do whatever is appropriate, use some default. Fail fast also is the same mechanism. But at the end, when we validate if the state at boundary is fine, is valid, then later we simply do not represent even invalid state, and we do not need to worry about it, that something may go wrong with the record because the internal state is inconsistent. And because it's immutable, we are sure that the state will be valid and consistent. And yeah, that's what I just discussed. Illegal states cannot be represented. We should take care of that by validation or by introducing some other types inside of this record. Moving forward, the other important aspect is sealed classes. Sealed class provides us exhaustiveness of type possibilities, so we cannot add any additional type to the class hierarchy as we defined. So we are sure that this class hierarchy is closed, and we cannot deal with this, that we cannot add anything else. No one will inject something that would break our code over there. And also, because inheritance is sealed, it's just validated at the boundary. We cannot add any additional class, or if we add additional class that is inheriting the sealed class, then other parts of code will just fail during the compilation. We will look into that with pattern matching. Yeah, that's again, we cannot represent illegal states if we have exhaustive types, and there's nothing more. We simply cannot represent something that compilator won't let us. Now, the other different approach to data-oriented programming, we can look at this, at records and sealed classes, as at the algebraic data types. So we are trying to model our domain using some dimensions, yeah? Having some finite number of values. And sometimes this finite number of values is very huge, and then we are using more a Cartesian product of the possibilities. For example, we have a record that have a name and surname. So we have all possible values. It's the Cartesian product of names and surnames. And each dimension is the number of possible strings in Java. Anyone knows how many strings is possible in Java? It's a very huge number. It's 2 to the 2 to 31, so it has over 9 million zeros at the power. It's more than particles in the universe. So yes, it's huge, but still it's finite. Still it's finite, but for our purposes we can treat it as infinite. So yeah, this is Cartesian product, and at sealed class we can look at it as union, as alternative. That we are choosing one of the values, and we have some enclosed set of possibilities, while this one is, well, practically unlimited. This one we limit specifically to know that we have just these possibilities and that's it. And we'll look into that also as an example. So with these approaches, we have classes, services, when we look from different angle as a code that is separated from the data. We discussed about data representation till now. Now we are talking about the code that is separated from data. And it should be in different classes and services. And for the common operations, we have a pattern matching, we have a deconstruction pattern, and in the future, something that will be helpful, value classes, Valhalla. That's, yeah, it's the future, and it's the future of the Java for last 10 years. And we have projects Lilliput also that also will be helpful making representations of objects smaller. It's closer than Valhalla actually. So quick comparison of OOP and DOP. Object-oriented programming is more appropriate for state-based systems when we are changing state quite often, when we mutate structures, and where the serialization is not so often or rare. Think about, for example, computer games. We have some state, but this state is volatile. We do not need to persist this state all the time. We do not need every frame being somehow put into disk, serialized, and so on. It's easier to have our hero walking and have his state and mutate it accordingly to our actions. So this is where object-oriented is simply better solution than data-oriented. Mutable structures, again, we have one hero walking and he's mutating his states, eventually getting killed. And serialization also is fair. We do save from time to time, not every second. Well, some people do, but that's extreme. And with data-oriented processing, programming, we have a data processing mainly over there. And when we think about commercial Java web services, this is something that we do very commonly. This is exactly it. We do data processing. We receive data, do something with that, and do something on output. Structures there are immutable, and the serialization actually is pretty common, yeah? That we have to serialize something to send over the wire to database or to the Kafka or anything like that. With technical aspects, we will not getting into all the technical aspects. I put just only two of them, but there is, of course, a lot of consequences of both approaches for the Java virtual machine, for the system, how it works. Here are just two advantages that we can find in both approaches, but let's not dig into that. Maybe later during the question session. So, code time. Let's see a little bit of the code. And let us start with addresses and sealed interface and records. Is it visible? There in the back also? Okay. So when we want to define something that is sealed, we just use the sealed keyword and we permit a couple of different addresses. We have a default one and Poland and Japan address and two methods that should be always there. Default address that should be used when we don't have anything else. It may look something like that. We have default address and we have two functions defined here. This is the constructor and this is also the constructor. But when we do not put the parameters, then this constructor is implicitly using all the parameters. So over here we are just invoking this constructor with null geo-coordinates. And this is example of the validation at the boundary. We are checking if the address is valid, and if it's not valid, we're just not creating an instance. And that's it. Also, as you can see, over here we have full address and geocoords methods defined. And records are defining by default the methods that has a name, has an attribute value. And by accident, these methods has exactly the same name over here. So with default address, these methods are implemented and they are returning this field and this field, but without any implementation. So we are fulfilling this interface address without providing any specific implementation because we don't have to, because fields are created like that. So now let's look into some more specific address. And here we have, because we have some default address, but let's dig into something that is much more precisely defined. And in Poland we have street, house number, flat number, city, zip code, postal city, and so on. We are also implementing address. But over here, address creation is much more complex, and the validation at the boundary and the entry also is much more complex. And we will not look into every aspect of that. And of course, still, I assume that it is simplified and real validation should be much more precise than that. But we are not allowing to create the object that is not legal. We are just throwing exception with description what is happening over here. As you can see, we don't have a full address attribute over here defined. So we have to override full address method to provide what is needed by interface. So we are doing it, and we are doing it in a way that is proper for Polish address. And as I mentioned about the code within the records, within the structure that is actually created for persisting, for keeping the data, but we have methods here. So these methods have two properties. One is for the validation at the entry, at the beginning. So we do not create illegal object. And the other one is just a function that is using the state of the object. It does not modify it, it does not do anything else. It is just kind of read model of anything that is in the object. It's kind of convenience method that this object, this record is exposing to be more useful. So this is, we can look at this as a more complex getter only. Whenever we invoke this method for the same object, it will give us the same result. And geocord is null. And just as an example, we have here a Japan address. Japan addressing is something completely different than we know from Europe and from Poland. We have, and this is very simplified, of course, because this is much more complex. I did it just only for example purposes. It's more like, you know, squares and getting more and more narrowed down and precise. So the full address implementation using this, you know, postal code prefecture and so on is completely different than in Polish address, but still it's the same interface. Yes, still it has full address, still it is the same. Now, how we can use this address? So let's look at a couple of techniques over here. We have just address created. We are just randomly selecting the address. And we can do switching over the type over here. So this is kind of the pattern matching. When we have address and we know all the possible classes that are implementing it, we can do switch case without adding default method, default clausule. There is no default. If we add new address, new type, compilator will raise an error over here that the switch is not exhaustive because you added new type. So this brings in, you know, in our data the type safety that is at the compilation level. And yeah, we'll be looking. You see, it's relatively simple. Yeah? Just Poland address, Japan address, default address, and here we are creating the instance that is type of Poland address. Of course, we can use here street, yeah, because it's in Polish address, and here we can use, for example, prefecture because it's Japan address. And in default, we have only full address. So A is the type, is of the type that is within the case. Now, when we want to switch not only on a type, but we want to know something more about this address. For example, we want to do something with Polish address when we are in Kraków, Kielce, or Warszawa, or any other city that ends in ów. We want to do some specific operation. Print some message. Then we can decompose this address, and the decomposition pattern, deconstruct actually, and the construction pattern looks like this. We ignore all the parameters that are here. First, we are checking the type. This is Poland address. Then we are checking what are the fields inside. Inside, we are decomposing them, deconstructing, and then using clausule when, we can use any expression we want to do the match to the data that we are interested in. So we do for the city in instance of Polish address, but we can go, of course, also into other addresses like Japan address. We don't have city there, we have a prefecture as a second parameter. and we are not interested in anything else. We are only interested in prefecture, for example, Tokyo, and we can do something on that. Now, over here, we can find a default clausel. Without the default clausel, there will be a compilation error. Why is like that? Because compilator cannot be sure that we covered all the possibilities using whens. Even if we know logically that we did it, then the compilator cannot guarantee that and is raising an error. That's why we have this default clausel over here, and this is why it's not needed over here. Okay, moving forward, let us see into some example that was inspired by the article by Mr. Goetz, that we have simply JSON value. Yeah? You know the JSON structure, I guess, how it looks like. We every day deal with JSONs. We have a couple of types there. So we want to model any JSON into Java types. And the JSON is actually the arithmetic type, as we discussed before, and has some finite number of possibilities. And this finite number of possibilities is modeled as a sealed interface with classes, records, and enums in this case that are implementing this. Here I used a different construction because I'm not putting the list of the classes that are allowed over here in this line. I'm just putting them into the class. They are embedded classes, embedded types, and they are implicitly allowed because they are in the body. So what we have JSON string, which has string val, so we know how record works, it will work. We have JSON number, which has some double value. We have also JSON null, and JSON null, it has only one possible value, it's null. So we do not have to provide any big record to wrap it, to have whole double space or whole string space. It's enough to have one value, and we have just null. Similarly is with Boolean. When we have JSON Boolean, we have only true false. What we would like to have is a boolval method, and it would be nice to make it like this. Yeah, this moment when I'm getting jealous with Kotlin guys, for example, yeah, it would be nice to write it something like this. Yeah, but it's not possible in Java. So we have to do it like that. And we have this boolval to represent if this JSON bool is true or false. And two more complex entities in JSON. We have JSON array and JSON object. That is, parentheses and other ones. And again, when we have this JSON value and we want to JSON string convert to JSON value object and JSON value object to the string. So here we can see the switch that is traversing through this value that is passed as an argument, and it's just simple case over all the possibilities that are over here. JSON null ignored, we could put something like this over here, of course, because we are not using the value at all. There is only one. JSON Boolean, we are using everything of that. And the serialization is pretty straightforward, of course. And we have all the types exhausted here. So you see, combining records and enums, we provided the full implementation of some algebraic data structure that we can manage right now. Otherwise, of course, also it's possible to create JSON value from JSON string. It requires more validation and it's a little bit more complex. Because it's just a string parsing, so we need to make sure that the string is valid. Yeah? So that's the reason why it is a little bit more complex. Okay, moving forward to the next example, let's see at the ID document. And with the ID document, here we have again, in a classic way, passport, ID card, driving license. I did it as a classes this time because it's also possible, of course, not only with records but with classes. And when we have a sealed class driving license that is implementing it, it still can permit some additional inheritance. In this case, it's international driving license that has some other properties, may have some other properties. So this may be still closed set of classes, but some subclasses are allowed there. And when we look at the ID traversing over here, when we have ID card, passport, driving license, yeah, we are reading this document depending on what the type is. And what will happen if, for example, we have to add new type, for example, perms type permit. So let's do it. ID document, perms type permit. Of course, now we have an error that it does not implement this interface. So let's go there. Implements ID, implements ID document. Now it's fine, okay. But now when we go to the address usage, not address, ID traversing, now we can see over here, we have a compilation error over here because switch expression does not cover all possible input values. And we have to add right now additional case, which is perms type permit P. And we can use unique identifier, for example. If we had, instead of that, if we had default null, then of course there is no problem, but we are just missing that we added something new, and we have to deal with this separately. Yeah? Okay, so here is also another example and something else in Java that I was exploring a little bit, just to randomize the document. When we are switching over a random number that we have bounded with 4, yeah, so we know that there will be only 0, 1, 2, 3 over here. Still, the compiler does not know what this method is doing, and we have to have this default over here. Yeah, this is not exhaustive switch statement. Even if we logically know there will be no other value than one of these 4, then we need to add default because there is no way to guarantee that. How we could make a guarantee that in this case there will be no other value? So we can do, for example, something like that. Define the enum 0 to 3, 0, 1, 2, 3. Make a random over here, why not? And here we can do a switch case. And there is no default right now. Seems a little bit overkill, yeah? Yeah. So even if we can do that, that doesn't mean that we always should do that. And think about adding this perms type permit, then what we have to do? Add another value to this enum just to incorporate that? Not exactly. This is something that Java is missing, but a lot of languages are missing. Kotlin also does not cover that. Having a kind of dynamic class hierarchy that will be validated by a compiler. So we have no possibility to tell compiler there will be 5 classes that will extend this interface. So count to 5 when trying to generate random one of them. There is no way to do that other than doing something like that, or just dealing with this and putting default. So there are limitations that we would like to do not have, but still they are, and we cannot do nothing about that right now. I don't think it's going to be addressed. Throwing. This is another example of throwing exceptions. This happens more often. This method is simplified. It throws a lot of exceptions randomly, but think about real methods that do the same actually. And we can deal with these methods with one catch throwable, also using pattern matching when we do something else on every exception. Of course, we need also default because exception types is not sealed, is not exhaustive, so we have to do something by default. Okay, moving forward. Oh yeah, what object-oriented programming is good at. You can read all of that. It's a hierarchy of the Java framework of containers, lists, sets, and so on. So this is a great example where object-oriented is working. We have clear interfaces, and we have some implementations that have different properties. Like think about hash set and linked hash set, or tree set, completely different properties, but still the set, or list and the set. Both are collection. but with completely different properties, and we are selecting the implementation that is proper to fits our needs, simply. So this is something object-oriented programming is good at, and we cannot forget about it. We are using it every day, of course, still. Moreover, data-oriented programming and the DDD, domain-driven development. You know domain-driven development, we do that for some time already. It has entities defined like this. Well, entity is one of them. So data-oriented programming can be some kind of perspective at domain-driven development, where repositories and services are represented as code, simply, where value objects are modeled as primitive type or record, where entities, again, entities and aggregates, by definition, they have identity and are mutable, but within the representation, they are not mutable in memory as an object, but modifiable in the repository by some kind of identifier that is related to that. As an object, it should not be modifiable. So these three are the Cartesian types. And the domain events is the sum type, so it just represents some closed set of events that may happen within the domain, and it may be easily modeled as some sealed class hierarchy over here. So let's look into a little bit of more code, not here, over here, when we have some domain defined. And this domain contains some order. You've seen 2 presentations ago the order, but I have no status over here. It has some order items, and this order, we have some customer. Customer can have some address, and we have some product that may be ordered. Yeah, it has a name and so on. So what I tried to do, I tried to see how all this that we've just discussed fits into popular libraries that we are using for persistence, like JPA, jOOQ, or simply JDBC. And to make it short, let's see first at the Hibernate. Let's see the customer Hibernate repository. So we have find all, we have find by ID, we have save, you have update. Of course, there are controllers, there are services also here. And in order, for example, to save the customer, well, JPA is not working well with that. As you can see, we have something like customer entity over here. So in order to make it working, we have to have entities that are JPA entities. Now it's Jakarta, yeah? JPA. And this entity have to be class, it cannot be record. It have to have this all properties that JPA enforces. And the only thing we can do is something like that. So the factory method that will convert the customer to the entity and the otherwise, yeah? The entity to the customer to have this one-way relationship only. So we can do that, we can use that, but it comes with the cost of this additional entity that is only for the JPA purposes and additional representation. No other way with Hibernate, unfortunately. There are some other libraries like jOOQ. Anyone uses jOOQ here? A couple of people. Okay, great. So jOOQ is looking at the data from different perspective, and it's actually very close to the JDBC. As with the JPA, the main focus was on the object, and we have an object and we are persisting the object and then getting the object from persistence. So the JPA is paired with object-oriented programming when serialization sometimes happen. In case of jOOQ and JDBC actually, data is main focus. We are focusing on the data and then represent it somehow as an object. So when we have the list of customers with addresses, for example, to retrieve from the database with jOOQ, we are writing using this jOOQ DSL, the query, and the only thing we need to add is some kind of mappers. So creating our records, and we can map the record to the record. Unfortunately, jOOQ named the records, the classes record, and now record in terms of jOOQ is something else than, than record in terms of Java. But still, with creation of such mappers, we can easily convert from the jOOQ to the record objects in both directions, of course. When we are saving customers, for example, here we can simply put the values using directly customer. We do not have to convert into any kind of entity. This is good enough. And in case of JDBC, it seems to be, it is very similar. Just the difference is between, main difference between JDBC and jOOQ is that here we write the queries as a string. In jOOQ, you write as a DSL. DSL adds some additional complexities, generated code, and so on, but brings in type safety into queries writing. Over here, we do not have type safety. We just check at runtime if our query works. But still, we can just execute the query and return the list of the customer, which is the record, using mapper similar that we were using for the jOOQ. So we're just mapping the single line from the result set, using some methods to get the string similar to the record in jOOQ, and to fulfill UUID, new address, and creating new customer over here. Okay, here is the whole structure that you know that is used to that. Let me show also some additional code that we have with this order. Yeah? For example, how we can use the composition, the construction of the records. We have an order service, for example, and we are operating in southwestern Poland. And when we deliver to some close German and Czech cities, we want to do some different delivery mode than usually. So how we can approach that? And here we have send order. Order has a customer, so we are getting this order and we are doing switch case by this customer. So first we have the VIP group, let's say. So we are checking within customer service if this UUID is a VIP. If it is, then we are doing some VIP shipment, courier, bring to their doors, and so on. If not, then we are interested into other aspects of this customer, and it's not customer directly, only his address. So we're decomposing not primitive fields of the customer, just we are decomposing the address and getting zip code and country. And if it's Germany, with the zip codes that are near the border, or Czechia with the zip codes near the border, or if it's Poland, because we are located in Poland, then we are shipping domestically. Otherwise, if this is any other address, we have to do international. Okay, if it is otherwise, if country is Poland, we also do domestic shipment as at the border. Okay, this one is not required because we have this line, yeah. So this one is not required. And by default, for all other cases, we are doing international shipment. So yeah, with these three different libraries for persistence, we have to do some effort, put some effort to do some mapping between the model that is used for persistence and model that we want to use as a data model in our application, in our domain. It's harder with JPA, easier with jOOQ and JDBC. There is no such a thing like a native support, but with relatively small effort we can do that. And approaching to the data as a data makes thinking about our program as a data-oriented program makes it easier. We are not doing object-oriented very often. We are doing data-oriented. So just shifting the focus on this data helps us to reason, to think, to model this in easier way. And at the end, couple of statements how to approach this data. And I think that's it. Thank you very much. Questions?
Could you show the slide?
Oh, yes. It's here? Yeah. Why to invent a new name for good old procedural programming? It's not good old procedural programming because there are some aspects that were not in procedural programming, like, for example, immutable data represented by records. So it's just evolution. So I see a lot of differences. Like we have this separation of encapsulation is there, isolation is there, immutability is there, separation of service from data structure is there. There were nothing like that in the procedural programming. This was not named, and procedural programming does not imply all of these properties. So that's the reason. Why don't you use? No, there's no any important reason. I just simply didn't use asterisks. That's it. Have already some patterns guidance regarding how to hold sealed hierarchies in code emerged single file. Well, emerged. That depends. It may be held. I'm not aware of any particular patterns that are described as patterns, how to hold these hierarchies. But how do I use it is to represent events and to represent some different states of the object if the nature is different significantly. So for example, operations of this on these objects in this state are different. So not exactly just the usages. What's the Java term for using underscores? There were the term, but I can't remember what was the term. Can you remind me? No, can't remember the term. Sorry. This. It's wildcard, not wildcard. It's blank something. I can't remember the name. Sorry. Yeah. Yes. Well, it's no, it does not extract the address. It does not create the address instance. It just extracts the primitive fields that were named in this address. So, well, let's address that later, okay? Directly, okay. Do you know if there is already any timeline for Java? No, and I guess it won't happen too soon. For example, you know that the date and time in Java occurred in Java 9, 10 years ago, and Hibernate just implemented that in Hibernate 3.1, which was a couple of years ago, 2 or 3 years ago. So it was the 6, 7, 8 year gap between data and time types and JPA usage of it. With records, I do not expect anything sooner. Okay, thank you then.